Hello and welcome to yet another live stream. I am Frank Lavinia. And follow me on Twitter. I have a podcast and um, blog. And this here is yet another rendition of. Usually, I stream on LinkedIn Live. However, I've upgraded my restream plan to include multiple platforms. So wherever you're joining me from, whether it's live or whether you're watching pre-recorded, I really appreciate it. Last night, I had the privilege to present to the Hampton Roads SQL Server user group. Of course, now we are in the viral apocalypse. So I did have to present remotely, which was good. And got into mostly the topic was kind of like the different types of machine learning. But one of the ones that really resonated and I enjoy talking about, I really do enjoy talking about this and geeking out hard on this, is reinforcement learning. And I am going to share let's see if I can do this. How do I put myself in the corner? All right. If I take my spotlight off, experimenting here with this technology. But ultimately, um, my picture option is gone. Something. Never a dull moment on a live stream. All right. So it combines the worlds of cognitive psychology, game theory, and artificial intelligence. It is a very promising field. In fact, what you're seeing here is it is probably the most exciting thing here because basically the algorithms teach themselves. Hence the reference to cognitive psychology. Um, and the game theory aspect we'll cover in this, and some very interesting and innovative stuff going on here. have kind of at least three core elements here. You have the environment, and you have the agent. And the agent will scan or observe the state of the environment. And the environment will then, based on what's inside the agent's policies and algorithm, will then take an action, which will hopefully alter the environment. It'll certainly alter the state of the agent. And then the cycle starts again. So you have kind of the updated state of the environment, and the agent will receive a reward. So how you reward a computer algorithm is somewhat of a leap of faith. But ultimately, what you're trying to do is you're trying to reinforce a certain activity, whether that's getting a score or taking down an opponent piece. And this really drives the conversation around that incentives drive behavior. So if you can have an algorithm be very aggressive when it's playing chess, because if it's programmed to get as many pieces as possible, it may not necessarily win the game, but it will be an aggressive player. Fun fact, I took this footage at the Costco on Saturday in the Costco lot. All right, so reinforcement learning has really found its strength. You, Lathan. I did not know that. Now I know that. All right. So the audio only comes in for me while I'm showing up on the screen, which is disappointing because you have to look at me, but also disappointing because if I do any live coding, I will have to. Write that code really large. I will have to file a ticket with the good folks at Restream because they've changed it to where, unless I do this, you hear me now. Thank you, Lathan. Thanks for watching live. All right, well, that's interesting. So I guess I'll try to code that way. Never a dull moment on live streams. But basically, if you've not been able to hear me, the key takeaway here is that reinforcement learning is an impressive and rather for a dull moment on a live stream. Apparently, I got booted off my own live stream because of a connection issue, which shouldn't happen because I have gigabit FiOS. So go figure. Yes. Okay, great. Lathan said he was following along okay, even though he couldn't hear me. Maybe that just speaks to either how good my slides are, but it's probably more for how smart you are. All right. So ultimately, that's what makes it exciting, is that ultimately what this is doing is trying to mimic the, I want to hurry up before I I get booted from my own live stream again. Uh, the original reinforcement learning algorithms are animal nervous systems, realistically, that ultimately your brain, uh, it's a lot more complicated than when I created this slide, but ultimately dopamine is kind of a reward system that, as I've kind of dug into this, and there's an interesting book I've been listening to called Evolve Your Brain. It starts off in kind of woo-woo land, but right now I'm in the middle of it, and I think what it's going to do is going to tie in. It really gets into the brain science here, and it's very fascinating stuff here in terms of how our brain will create thoughts, which then create chemicals in the brain, which produces emotions ultimately, and physical reactions to these emotions. I think ultimately, looking at the chapter list, I think he's going to go from the original woo-woo land and using science. Now we're talking about brain chemicals and brain structures, and I think he's going to loop it back into kind of like, how does that relate to kind of the things that are less provable by science but more metaphysical. It's an interesting book, so I'll let you know when I'm done with that. If you want to play along and you want a free audio book, you can go to thedatadrivenbook.com. The Data Driven Podcast gets a kickback if you sign up for a subscription, but hey, you get a free audiobook in the process, and you help support the show and streaming like this. All right, that was a bit of a sidetrack, but basically, dopamine is essentially a key component, chemical component to the reward system that keeps us alive. It's not perfect. If you look at how addiction happens, whether that's addiction to anything from drugs to behavior, it's not perfect, but here we are. And think about how child development works. Kids learn from their environment. They're not quite blank slates when they're born, but they do pick up behaviors, whether that's cultural norms, learning manners. Having since we've been on lockdown, it's been kind of a struggle with the younger one. Or really about the things that pets figure out. If you have pets, if you don't have kids, here's a good example. I have a very smart. I have 4 dogs right now, and this one is very clever in terms of her ability to get food. She can really. She's figured out how to do things, whether that's waiting by where the kid is to when they're done eating, or if they happen to look away for a second. She has figured out how to move the microwave. Open the microwave. We have one of those drawer microwaves. And recently she's actually figured out how to open the freezer and serve herself some frozen meat and other treats and ice cream. So animals do have this capacity. This was interesting here is she would know that my son would only, we'd give him 3 waffles. She would know based on his kind of body behavior and speed at which he's eating of when he was about done to eat. He'd just walk away, and then she would steal that stuff. And if you want some entertainment, there's just look at the hashtag Weimcrime. She's a Weimaraner, and they are very intelligent in terms of how they can get themselves into trouble. But today I'm going to be talking about the multi-armed bandit problem. Multi-armed bandit problem is a problem, as a kind of a sample problem that you get in reinforcement learning. It ties together some aspects of game theory along with some core aspects of reinforcement learning. So basically, it's a kind of a contrived scenario where you have a bank of slot machines. In this example, there's 5. And you want to figure out which one pays out the most. Now, the ground truth here is the odds of a payout across all of these is 10%, 25%, 5%, 33%, and 5%. Now, realistically, no casino would stay in business very long if the odds were really good. That's why I say it's a bit of a contrived example. So this gets in the idea of the greedy epsilon algorithm. And basically it goes back to that song, Should I Stay or Should I Go? And it's about striking a balance between greed and curiosity. And essentially, the problem here is, let's think about, remember what old Gordon said, um, and I can actually prove mathematically through this experiment I'm about to show in my notebook, that at least 5 to 10% of the time, being greedy is a good thing. So here's a demo. We can't quite travel to Vegas, but we can experiment the power of data science in Python. All right, so I'm going to share this screen. This actually was an article in MSDN magazine, and I am trying to dig up that link right now, right here, where I kind of go through this. The code is there. There should be a link to this notebook too, but I will do this and attempt to share, to manipulate the screen. Oh, there we go. Yeah, that's not awkward at all. All right, so in the remaining 5 minutes I have left, I will go through here. So basically what I'm doing is I'm importing a bunch of these libraries, and I'm setting up the number of slot machines. The code set up so I can have 5,000 slot machines, and you can kind of test how that goes. And I basically create a series of random numbers that predict or that will determine when there'll be a payout, right? So in this case, it's 54%, 27, 42, 84, and 0.4%. Let's see if this cached from before, or is it going to give me a hard time about reloading my PyPlot stuff? Yeah, might take a while because it's doing that. All right, serves me right for not running this ahead of time. But in the interest of time and your attention, I will go through this. So basically, we know what the ground truth is in terms of what the odds are. So I'm going to create. Now, I know you're probably thinking, hey, you already know the answer. Why is this good? Yes, greed is good. That's right. Thank you, Thomas. So what's happening here is I'm setting up a. Hey, how come it didn't render my little plot? Okay. So now I can kind of actually run the things. So what I'm doing here is I'm setting up a series of basically zero values where I don't know what the odds are, right? So I'm going to zero it out. I'm going to create a function here in Python that basically simulates playing a slot machine. Sorry, no cool graphics or sounds, but that's not what this is about. If you hit the jackpot based on the slot machine and its payout ratio, it will simulate this, the slot machine. And if you hit the jackpot or that random number is less than that, then it will give you a reward of 10. Otherwise, it'll take away 1 point. This is to simulate, every spin of that, or every pull of that arm represents a risk, right? So the risk is fixed, and then the reward is higher. Now, yes, in a real situation with jackpots, that would be a sliding scale. That would probably be multiplied by some random number, but I'm trying to keep it simple because it's not about this here. So I'm going to run this line here. And of course, it's not working. Why are you not working? Oh, because I didn't run this cell. All right, so basically this is playing these machines multiple times, and we're kind of seeing what the output score is. So you'll see some of them pay out, some of them don't. All right, so what this is defining the multi-arm bandit, simulating a bank of these things. And what this is doing is let me define that function. That function is now defined. So now I'm going to run this, and I want you to notice that there's something called an epsilon. And what an epsilon means, let's see if I can pull up the whiteboard I did last night on this. I spoke at the Hampton Roads user group. That's not it. Here we go. Come on. No. It didn't save. Oh, here it is. Epsilon represents a number between 0 and 1. And ultimately, this is the explore versus exploit dilemma, right? So what you want to do is you want to get you have to define, if you hit a winning jackpot and you're happy with it, do you exploit that resource, or do you explore in the hopes that there might be a better horizon around the corner? And basically, this is represented from a number between 0 and 1. 0 means basically there's no greed at all. Greed is basically about being exploit. You want to exploit everything, right? And basically, it comes down to like the song says, "Should I stay or should I go?" Basically, if you're set to closer to 0, it's exploring, and you want to try all the slot machines, right? So you're going to hit them all. Alternatively, on the other extreme is you want to stay with what works, and that's being kind of greedy, right? And that's why this is called epsilon greedy. Remember, math, game theory, those folks in the math world love their Greek characters, and that's ultimately, oops, let's see if I can zoom out, ultimately what you want to do here. Hopefully that makes sense. All right. I figured I'd draw it again, but why? I don't have a lot of time here. All right, so what I'm going to do is just going to, in the interest of time, because I do have to pick up the youngins. Awesome, you hear me. Thank you. Thank you, Mohammed. All right. I'm going to run these all, and basically what you're going to see is these are the actual odds, and this is what the program figured out the odds are. And you'll notice that they're actually pretty close. And this is with the epsilon of 0.9. And that means that it's going to mostly stay put, but it's going to be a little bit greedy, 10% greedy if you can quantify greed. Now, I want you to also notice that the number here, that's the reward. That's the amount of money that the bot earned. If we go here, where it's not greedy at all, it's just it knows what it knows, and it basically never left the first slot machine. So I actually had them 1 and the 0 reverse. So apologies for that. So basically, what this is doing, it's not greedy at all. It's just going to keep playing the same slot machine over and over and over, and it never got beyond the first one. And its reward was 5,200. Now the other extreme is you're greedy, right? This is the Gordon-Gekko algorithm, right? This is the epsilon set to absolute greed. And what do we have here? Well, we know all the odds, although it's kind of very pessimistic on this one. But what you see here is that the payout is there, but the rewards, are actually lowest. So I experiment here with a 1% greed, and it's 6,700. So what's interesting here is that the highest score that I've been able to experiment with is somewhere between 10 to 15%. And that's also what the research thing is, but it's kind of cool. I can verify that here. And it doesn't matter if you expand this to 50,000 slot machines, it'll still be the same in terms of 10 to 15% of greed is good. So with apologies to Gordon-Gekko, that's basically all I got. Hopefully this cleared up some things here, but I want you to notice that there was no neural networks in there. This was just strictly probability and remembering, right? And I'll also have an article, and this is also another thing I'm going to do, is about how memory is crucial to learning. Now that makes sense in a just an obvious kind of way, but it is interesting to kind of see how memory evolved and developed in biological systems and why those are also important for learning in artificial systems. So with that, it is 5:03 and I am 3 minutes over. Thank you for watching live in real time. Thank you for your comments. And with that, I bid you adieu, and I hope you have a great day. I'm on air. Okay. Thanks, everyone. So in case you're wondering why I had that confusion there. It's because it said to go live, but I'm already live. So seems like the folks at Restream have some work to do on their UI.